Welcome back to part 2 of our restaurant reservation system tutorial. In the last video, we laid the foundation by designing the core classes for our system, such as restaurant, table, reservation, and customer. If you haven't seen part 1 yet, I highly recommend checking that out first. In today's video, we're going to take our system to the next level by implementing the core functionality. We'll walk through the methods that bring everything together. Get availabilities, which allows us to find available tables based on location, time, and party size. Make reservation, where we'll handle booking a table for a customer. Cancel reservation, which will let us remove a reservation and free up a table. And get reservations, which will help us list all the reservations for a specific restaurant. By the end of this video, we'll have a fully functional system that handles everything from checking availability to making and canceling reservations. So let's dive in and start building. The database context class acts as an in-memory database for our restaurant reservation system. It holds lists of objects like customers, restaurants, tables, and reservations. These lists are initialized in the constructor, and they store all the data the system needs to operate. By using this class, we can easily simulate database operations, allowing us to query and manipulate data without connecting to a real database. This method is responsible for retrieving available time slots for a restaurant based on the location, a specific date and time, instant, and the size of the party. In the getAvailabilities method, we begin by querying restaurants in the specified location. It filters restaurants from the database db.restaurants based on the provided location L. Then for each restaurant, we look for tables that have enough capacity to fit the party size. For each restaurant, it checks tables that can accommodate the requested party size. Finally, we check if the requested time slot is free by verifying that there are no overlapping reservations within a 90-minute period. It checks each table's reserved time slots to ensure there are no overlapping reservations within a 19-minute window of the requested time, instant DT. If a table is free, we add that time to the list of available times for that restaurant and return the results. If no conflicts are found, it adds the requested time to the available time slots for that restaurant. Now let's take a look at the make reservation method, which is responsible for booking a table for a customer at a specific restaurant and time. We start by counting all the existing reservations in the system. This helps us generate a unique ID for the new reservation. This ensures that each reservation we create gets a unique identifier. Next, we filter the restaurant's tables based on their capacity. We're looking for tables that can accommodate the size of the party. Here we only select tables that can hold a group equal to or larger than the requested party size. This is important because a party of 6 can't be seated at a table meant for 2. Once we have a list of eligible tables, we look through them to check if any of these tables are free at the requested time. We ensure there are no conflicting reservations within a 19-minute window. Here we're comparing the requested time dt.time with the times of existing reservations inst.time. If the time difference is less than 19 minutes, that means the table is already booked for that time. If no conflicts are found, we assign the table and add the requested time to its list of reserved instants. This marks the table as reserved for that specific time slot. Once we find an available table, we break out of the loop since there's no need to check the other tables. Now that we've found an available table, we create a new reservation object. If we have a valid table, we then populate the reservation details. Here we set the reservation ID, restaurant ID, customer ID, party size, date and time of the reservation, and the ID of the assigned table. Finally, we add the new reservation to the list of reservations in the database context and return the reservation object. In this method, we walk through how to find an available table, book it for a customer, and create a reservation in our system. The method ensures that we only assign tables that can accommodate the party size and that the time requested doesn't overlap with other reservations. Now let's move on to how we can cancel a reservation in our system using the cancel reservation method. This function will allow us to locate the reservation, free up the table that was reserved, and finally remove the reservation from the system. The first thing we need to do is find the reservation we want to cancel based on its ID. Here we query the database to find the reservation that matches the ID of the reservation R passed into the method. We use first or default to get the first result or null if no match is found. Next, we locate the restaurant where the reservation was made. This retrieves the restaurant that matches the restaurant ID in the reservation. Once we have the restaurant, we need to identify the specific table that was reserved. This gets the table that was assigned to the reservation based on its table ID. Next, we locate the exact instant, date and time of the reservation for that table. This query checks the reserved instance of the table to match both the date and the time of the reservation. If a match is found, we store it in the instant variable. Once we've identified the reserved time, we need to free up that instant from the table's reservation list. Here we remove the instant from the table's reserved instance list, making that time slot available for future reservations. Finally, we remove the reservation itself from the database. This deletes the reservation from the reservations list, effectively canceling it. So the cancel reservation method does a few key things. It finds the reservation, the restaurant, and the table where the reservation was made. Then it frees up the reserved time for the table and finally removes the reservation from the system. This is how we ensure that when a reservation is canceled, the time slot becomes available for other customers. Now that we've covered making and canceling reservations, let's take a look at how we can retrieve all reservations for a specific restaurant using the getReservations method. This method takes in two parameters, DB, our database context, which simulates the database, R, the restaurant object for which we want to retrieve reservations. We start by declaring an empty list called reservations that will eventually hold all the reservation data for the restaurant. Here we query the db.reservations to find all the reservations that are associated with the specific restaurant R. We use the restaurant ID to filter out the relevant reservations, ensuring that only reservations belonging to the past restaurant are selected. The toList method converts the query result into a list of reservation objects. Finally, the list of reservations is returned, allowing us to access all bookings for the specific restaurant. So the getReservations method allows us to get all the reservations for a specific restaurant by simply querying the reservations table for that restaurant's ID. It's a simple yet important method to help us track bookings for any restaurant in our system. In our next video, we'll dive deeper into how these methods work together, and we'll also explore more advanced features you can add to your restaurant reservation system, like modifying and updating reservations. Make sure to subscribe so you don't miss that.